few years ago, I did a Kickstarter, but unfortunately, I didn't succeed. About a month ago, I was digging through my yard and found a mysterious buried box. I was a little taken aback, but then quickly realized it was a time capsule. But it wasn't just any time capsule. It was a time capsule with my Kickstarter project in it. I'm kidding, I was going through one of my drawers and found my old Kickstarter project box. Discovering it again made me have a great idea. The project was so much fun, and now it's sitting in a box, hidden away from the world. So I decided to remake it. And this time, open source it. At the end of the video, I'll share a link to all the files and all the designs that you would need to recreate one of these. So stay tuned. Now, let's get into the fun part, requirements. You're probably asking, why not simply release what you already had with the previous project? Well, I like to complicate my life. A little bit, okay? A little bit. But no, that's not the reason why. Initially, I made the design using a Bluetooth module and an ARM microcontroller. Now, these are great. These are awesome. But one, they're fairly expensive, and two, they're not easy to use. As to say, compared to an ESP32. And ESP32s over the last couple years have gotten smaller. The modules are tiny nowadays. There's a very big community behind them. And I felt that switching to something like an ESP32 would open the door for more people to actually try this project, since this project will be open sourced. The ESP32s come with a range of peripherals, and my favorite is BLE. And since I want this little card to be BLE controlled, that way I could control it from a computer, I could control it from a phone, or I could control it from a custom remote. ESP32 plays the perfect part here. Originally, I made an app for the phone, specifically an iOS app. And this app was used to control the little car and for the game logic and so forth. Oh man, where do I start with apps? Apps have to be maintained because the APIs change over time. They are hard to compile, to even get running in a developer setting. I feel like every single IoT nowadays comes with an app. So, no apps. And that way, it's easier for you to simply recreate the hardware, flash it, and get it running. But we'll get to the requirements of the controller in just a few minutes. But it'll be a physical controller. Mechanicals. I want this to be a 3D printed car. I want the enclosures to be 3D printed, and I want them to be fairly simple to 3D print. That's a requirement. So, it has to be a car with minimal number of moving parts. A car with minimal number of moving parts. So I could do the same thing as I did in the original project. In the original project, there were 4 motors, individually controlled. So if you have side A and side B, you could speed up, let's just say, side A and slow down side B to turn in a specific direction, in that direction. That's basically a tank. Let's do it. And as in the previous design, I don't want this to be just simply a little car that drives around and does nothing. So, like in the original project, I'm going to add a color sensor, and this time I will throw in a magnetic switch into the equation. In the original project, one of the problems was that if you're driving on a colored surface, the car would pick that up and it would spin out, for example, or it would speed up and so forth. So it would trigger the game logic, even though it shouldn't have.
Probably look ridiculous playing in a kid's room.
This time around, I'm throwing in a magnetic switch, and we'll have to figure out how to trigger it. But I'm going to throw in a magnetic switch, so that way if you go over a colored surface, it doesn't trigger anything. It doesn't do anything until it gets a signal from the magnetic switch that it's time to read that color sensor and it's time to process it. Let's use AI as well. I'll get to that in just a second, but keep that in mind. We need batteries. Let's use a LiPo. You could draw a lot of power from them very quickly. You could charge them fairly quickly too. The biggest problem with LiPos is that you need a specific charger. I'm gonna make the charger on board. I don't like having lost chargers and not being able to use the toy anymore because I can't find a charger, or being scared to plug in a random charger that I have found because it might not be it. So this way, all you'll need is a USB-C cable. That sounds good. And finally, let's add some flair. We need some LEDs. Let's do headlights and taillights. After all, it is a car, right? Okay, one last thing, I promise. Let's add a switch. I could add a button that just triggers an I/O and wakes up, but then it drains the battery. No, let's do a physical switch. I like physical switches. Done. Oh man, that was a lot of requirements. Let's make it. Wait. The controller. All right, let's go into the controller. For the controller, we could keep it simple, right? Oh, a little simpler than the car, maybe. It needs to be 3D printed, so the same thing as the car. That way it's easy to reproduce. That's a check. Again, we need to have batteries. So let's utilize the same circuitry as we are using on the car. That should be fairly simple to redo. Let's use a LiPo and the same charging circuit. That's a check. We need to have buttons and some sort of a joystick. Yeah, that sounds like a plan. Let's do buttons, just like a Nintendo Switch controller, and add a joystick so we could have proportional control. And let's do buttons so we could, I don't know, speed up, slow down, change modes, and so forth. And let's add some flair. Let's add some status LEDs. Okay, that's it for requirements, I promise. Now, let's actually make it. After sweating a few days in front of a computer and a couple failed designs, I was finally done. And the result looks amazing. I cannot wait for all the parts to come in. After patiently waiting a few days, the PCB parts finally arrived. It's assembly time. Call me crazy, but I have a pick and place at home. While this might be an overkill, it helps me speed through PCB assembly. It used to take me about 3 hours per PCB to assemble an average board of 80 components. Now, it takes me less than 30 minutes. The pick and place is not perfect. It does about 90% of the components, and the 10% left over I do by hand. That's not a big deal. All the passives, all the capacitors, all the resistors, things that are common, such as 0.1 microfarad capacitors, 10K resistors, and so forth, all of it is placed automatically by the pick and place. I love this thing. And the boards are looking great. Check it out. I designed the enclosure for easy printing and assembly. The motors snap into place without any screws, and they hold without any glue. The PCB mounts on top of an enclosure with a tiny help of double-sided tape. The motor wires fish through the enclosure and the PCB for a nice solder at the top. The battery fits snugly under the car, again double-sided tape. The color sensor and the magnetic switch are on a separate little PCB of their own. They connect via a 1.27mm header. That way they are spaced away from the PCB and are as close to the ground as possible. You want it to pick up only the color that it's actually supposed to see. So we're trying to get as close as possible here. And also for the magnetic switch, since my magnets are going to be fairly weak, I have to trigger, and therefore we have to get as close as possible as well. There's a little problem though, the wheels. Oh man, I tried extrusion 3D printing for the wheels. That didn't went well. The wheels are so tiny and they're so detailed, I had to pull out my resin printer. And while the resin printer achieves extreme accuracy, I really don't like dealing with resin. It's messy, it goes all over the place, it smells, but the precision you achieve, it's unbeatable. So the wheels are 3D printed using an SLA printer. And even then I failed multiple times when 3D printing those wheels. Things didn't stick to the platform, the resolution wasn't correctly set, and so forth. After a few failed attempts, I finally had a wheel that worked good enough. It's not perfect, but it'll do. Now, for the remote. For the remote enclosure, I decided to use screws. They're self-tapping M2 screws. In the end, I do want my kids to have fun with this project, and so all the electronics, as much of it as possible, have to be hidden away from those little tiny toddler fingers. So for this board, I had to make it double-sided. Some of the electronics are in the front, only the electronics that are necessary, such as buttons and the lights and the analog switch, or rather the analog joystick, they are on the front side, and then everything else is on the back side. Depends how you look at it. Anyway, looks good. PCBs came out great. After a few days of programming, I had all the basics functioning. This thing is pretty fun, but we're not done yet. There's still that color sensor on the bottom of this thing. Let's get it working. Well, as mentioned before, I decided to make my life easier by writing a neural network. Oh man. Right. So I asked a large language model to help me with this. Since I am slightly familiar with neural networks, I have read some books, but I have never really actually written a neural network myself. A large language model today can help you guide you through even some of the most difficult problems, which is great. I was able to write the actual neural network that goes onto the microcontroller of the little car, and then I was able to write a training algorithm to train up the neural network. The training algorithm is used to set the weights for each individual neuron on the neural network. Next, I had to collect some real-life data and train the algorithms. And after a few days of hair ripping, I finally managed to get it. And when I saw the car outputting the right colors, telling me that it's seeing red, blue, and so forth, oh man, it was an ecstatic moment for sure. Okay, now that we've harnessed the power of AI, the neural net, it was just a matter of creating the game logic. Since the car is inspired by Mario Kart, there had to be spin-outs, speed-ups, and slowdowns. I used these colors and shapes, don't judge me. The green banana makes the car spin out. The white cloud makes the car have a temporary boost in power. The black oil splash makes the car slow down for a couple seconds. But these shapes hold a little secret beneath them. Each one has a magnetic sheet below the vinyl. The magnetic sheet triggers that magnetic switch that we talked about before, and that sends the signal to the microcontroller that it's time to check what the color sensor is seeing. Then the color sensor takes its raw data, processes it through the neural net, and basically makes the car do certain actions or no actions at all, depending on what it sees. It works. It's pretty cool. Oh man, this project was a blast to recreate, and I've been having a lot of fun playing with my kids with this car. I even went looking for monsters under the bed. I hope you enjoyed going through this project with me. If so, consider subscribing. It was a lot of fun to make for sure. As promised, here is the link to all the files. It's also available in the description below. I have some really fun projects planned for the future. Stay fun. I'll see you in the next one.